Hello everyone. First of all, let me introduce my team. My team has two members. My name is Nhat Phuong and my friend Nhat. With the topic AI Big Data's way approaches for monitoring, detection, and diagnosis, we chose the proposal named Application of Deep Learning in Detecting COVID in Chest Radiography with YOLO Convolutional Neural Network Model. We have divided our presentation into segment parts. The first is background, the second part is significant and goal, the next part is approach, next one is specification, pitfalls or alternative, and the last part is impact. Let's go to the first part, the background. As you know, in 2019, the COVID-19 poses a zero threat, even though it is caused by an infectious agent. Infectious substances, even when combined, form small lumps. Various efforts are made to diagnose COVID-19 using machine learning and artificial intelligence quickly and accurately, and information such as symptom and chest X-ray finding can detect COVID-19. Moreover, recent studies suggest that deep learning can be used to evaluate chest X-ray and provide radiologists and technicians with important second opinion in the decision-making process. Several studies have reported superhuman performance in detection of COVID-19. Do you know World Health Organization recommends the use of real-time transcription-polymerase chain reaction as the primary diagnosis methods for COVID-19 detection? Chest X-ray or chest computed tomography scans are also commonly used, but are recommended only when RT-PCR tests are not available in a timely manner. The RT-PCR test has low success rate of 70% and a sensitivity is from 60 to 70%. Moreover, a few negative cases of RT-PCR tests show the positive results on chest X-ray imaging, and we see that chest X-ray appear promising for emergency and treatment due to the speed of operation, low cost, and easy use for radiologists. We have some purpose for our methods. The first is develop the automatic COVID-2020X in chest X-ray to support clinical decision. Next is assess the clinical applicability to deep learning system for COVID-2020X screening and detecting. The last reason is finalize a good methods with acceptable accuracy. Here the way we approach the proposal. Initially, we found the information about CNN. CNN means a convolutional neural network. It is a type of artificial neural network using image recognition and processing that is specially designed to process big data. One of the benefits of CNN is that it automatically detects important features without any human supervision and making it the most widely used. To make it easier to imagine, I have an example of CNN. In CNN, the original image is multiplied by one kernel matrix. From that, we have new corresponding image matrix that include features of image. Then, from this feature, we can classify images. This brings me to the end of my presentation. Next part, Nhat will introduce about YOLO V5.
Hello everyone, my name is Nhat and now I will continue the presentation of Phuong. And firstly, I will talk about our approach. And so, what is the YOLO V5? The YOLO algorithm here is a term you already look once. It is a redefined target detections at a single regression problem directly from an image pixel to bounding spot coordinate plus probability. The YOLO algorithm can see the entire image during the training and testing time, especially about the class and appearance. For YOLO V5, it has 4 different versions with corresponding architectures. First one is YOLO V5S, which is a small version. The YOLO V5M, which is a medium version. The YOLO V5L, which is the large version, and YOLO V5X, which is an extra large version. These 4 versions here have its main strengths and weakness, and for the larger architectures, that has a higher accuracy, but the training speed and the interference is not really good at the smaller architectures. Then we'll talk about our specific aim. Here is a process. We got the 6 main steps that we mention in detail below, and I will mention after this. In general, the original image will undergo a pre-processing process before they classify in the data classification step. And in this step is where the image will be divided into normal and abnormal images. After that, the YOLO file was used as a framework for the training to create a model for predictions, which will be more apparent in the prediction step. And finally, the project will test the result by comparing the training model with the original images, and which we already labeled the disease. And now I will talk more about the detail of each step. In the pre-processing step, the system will read the data and resize the image to match the format of YOLO file. After that, we will calculate the weight and the height of the image before doing the histogram equations and normalizations. And finally, we will do the annotations merging. In the data classification step, the method splitting the data into abnormal image and normal image. The reasons for splitting is we use the abnormal image for the training to maintain the outcome. The next step is the training by using the YOLO file. The training including 5 rounds. Each round needs to phase is a hyper and phi 2. The hyperphase creates the initial model based on the beginning format of the YOLO. And this type of model is a variable 5 of YOLO file. And after the training of the hyperphase here, the project will generate a new file, which is a new model, by go to the phi 2 phase. And in the phi 2 phase is used to make a new model based on the hyperphase reform, which makes the model with a better accuracy. In the prediction step, there are 3 main phases. The first one is the predictions by letting is the result in the phi 2 to create the annotations for each image in the testing phase. And the last one is the testing step. We compare the results by drawing the bounding box to detect the abnormalities. Here is our pitfalls or the alternative. The main issues of our approach is the accuracy. So we propose here is 2 solutions to improve the accuracy. First, we combine with other model. That means we combine the YOLO file with other model. Although the YOLO file get a high speed and better accuracy than other versions, but the accuracy is just still at the average level. So our idea is combine the YOLO with other model like the fast RCNS, and so that we can use the chance of YOLO as the speed, and the high accuracy is the chance of fast RCNS. Also, we increase the number of data by rotating or flipping the image, and that's called the image data augmentations. And so that we increase the number of the image and also increase the number of the case and the situations so that the accuracy can be improved. And finally, we come to our impact. The applicability of this system is to ensure the patient choice with the minimal radiological symptom of the new COVID is limited. However, if the radiological symptoms of the COVID-202X are present, these tools can accurately detect and identify them. And that's all for our presentation. So thank you for your listening.